So in this demo, we'll be working on the installation of Apache Spark, and we'll be covering overall in fundamental depth about Apache Spark and its components, its streaming distributions, and basically the fundamentals of Apache Spark. So we'll be first go through the installation steps of Apache Spark on Ubuntu. So to install Apache Spark on Ubuntu or CentOS or RHEL, we need to first go through the installations of Java. So the command to install to Java in any of the Linux distributions, you need to either take a repository, just like this command, then you need to take an update, and then you need to install the Oracle Java. You can go through either with Oracle Java or OpenJDK, but make sure that if you are planning to deploy the latest versions of Spark, that's either 1.3 or 1.3.1, so make sure that you are deploying JDK at least 1.8. But if you are planning to deploy the older version of Spark like 1.1, 1.2, then JDK 7 is fine. So in this demo, what you have done already, we have already installed Java. So let's show the Java version. So we have installed the Java version 1.7.0 subversion 8.0. After the installation of Java, the next step would be to install the Scala. So Scala is basically, it's a language, it's one of the object-oriented based programming language. It's very familiar with Java, very similar with C#, and developers who are familiar in coding with Java or C#, Scala is pretty much friendlier platform then. And so we need to install Scala. So for that we need to download the Scala package. So you can take out any of the standard Scala package from any of the standard mirror. So you can also download it from this link directly, that scalalang.org/files/archive/scala 2.10.4.tgz. So you can download 2.10.4 tgz, but make sure that the version of Scala that should be compatible with the versions of the deployed edition of Spark, because the working principle of Spark, it's being dependent on the version of Scala that we are going to deploy, and Spark in backend, it also works on Scala. So first you need to download Scala, and after downloading you need to extract the Scala package, and once you have extracted, then you need to add it to the local Linux directory. So what we have done here, we have already deployed Scala in this cluster, and we have moved it into the user local Scala directory in the local Ubuntu cluster directory, and here we have all the specific Scala components right now which is with us. And at the end we have also changed the environment settings, that's the environment variables for the deployment of Scala. Just like normal Hadoop deployment, just you need to add the Hadoop variables. Similar things you need to do for when you are deploying Scala. So you need to first add the Java path, which is good, and then you need to add the Scala home, and then you need to just configure the path with the Scala home/bin. So once you have done so far in this way, just type Scala and you'll be able to see the Scala shell. So Scala shell is it's a raw shell where we can write the normal Scala programs. So for Spark installation, this step is mandatory, and of course after the installation of Scala, you could be able to check the version of Scala that you have deployed. So you can just type Scala version and you'll be able to see the version of the deployed Scala. In the next step, what you need to do, you need to install Git, because Spark builds, sometimes it depends on Git. So if you are planning to take any Spark build directly from GitHub, you can install Git. Otherwise you can just go ahead and choose any standard mirror and go ahead and download Spark from that URI. So once you have downloaded Spark, so you can just extract. So what you have done, we have already downloaded Spark. That is how in this demo we are working on the version 1.2.1 tgz format, which is the default package. It's a tar package, tarball package. And next step, we have just extracted the tarball package. So once you have extracted, you can go inside the directory and you'll be able to see that some of the specific folders would be there, so some of the specific directories. And after that, what you need to do, you need to build the Spark with a tool called SBT. So SBT is basically, it's a tool that is based in Scala. It's built on Scala, and its full form stands for Simple Build Tool. It stands for as SBT. So SBT is written also in Scala, and this tool you need to use to build a Spark, which needs to be bundled with that. So in order to compile the code, the command that you need to run for Ubuntu, if you're running, you can just type sbt/sbt assembly. But make sure that before executing this component, before executing this command, you must have Maven to be installed in your cluster. If you don't have Maven installed, you'd receive an error. So since already I have installed Maven, so I have also executed this command, and I have built at all the specific libraries and assemblies. So build would take after some time, but after successful building, of course, you can take a sample program. So what you can do right now, since I have already just built Spark, so I can just go ahead and run a sample program. Just can type run example Spark Pi, because I'm just taking on example on Pi, and 10, just being assigning the values. So Spark has just executed. So next question would be how to start the Spark shell. So there is a shell is being available in Spark that's called Spark Interactive Shell. So you can run Spark interactively through Scala shell. So the command that you need to fire up to get to the Spark shell is basically bin/Spark shell. So we are able to get the Scala shell. Now if you want to check some particular sections of Spark using shell, for example, just like if you want to run MQTT interactively, MQTT would be defined under external for importing into Spark shell. So in that cases, just follow the instruction. Just can write, suppose in the Scala also you can write a little bit simple program. Just add some simple RDD. RDD stands for Resolve and Distributed Dataset, which I'll be talking next. Spark Context Object, and using Spark Context Object, I can call a file, and this time I'm just importing a simple file from the Spark package, and after that I can fire up a simple action. So the total count of the file is total word count is 98. Also we can add a simple driver class path to the Spark package. So in order to add the class path, what you need to do is basically just can come out from the Scala shell and just can write Spark shell driver class path Spark streaming, and you can add this jar that's called mqtt underscore 2.10 1.1.o.jar. That's all. Spark would go ahead and would start the Scala shell so that we can import the package, respective package. So just can add the Spark package streaming.mqmt. Sorry. So like this way you can import the external packages, and next you can check your code line by line. Now if you are planning to access the data from HDFS, just if you are trying to access directly from Hadoop file systems, so you just already have to the build source package, just rebuild it once again against the Hadoop version. So what you need to do, just come out of here and just clean the environment with SBT, and you can change this by setting the Spark Hadoop version variable. So you can either go for Hadoop 2.2.0.o -cdh 4.3.4 if you are planning to directly work with the version, Hadoop version. So you can check with this following version 2.0.o cdh 4.3.0, and what you can do is basically you can just add this following line in your bash RC Spark Hadoop version mr1 cdh 4.3.0, and that's just you can type SBT. Next you can build with the help of this assembly. So after successful build, you can of course go ahead and read and write data into CDH 4.3 clusters like this way. So also Spark is actually being consist of an interactive analysis with the Spark shell. So Spark shell actually it provides a simple way to learn the API, as well as it's a powerful tool to analyze the data interactively. So it's available in either Scala, which runs on the Java VM, and thus it's a good way to use the existing Java libraries as well. Or you can also write the programs in Spark in Python as well. So you can start by following Spark directory. We have already checked that how to open a Scala shell. So what I'm doing right now, let me show you how to open the Spark libraries, how to write the Spark libraries using Python. So basically you can just type bin/PySpark. PySpark is a Python library for Spark, and you can go ahead and type the Python libraries for Spark. So this is the Python library for Spark. So here also you can write the same program using Spark context object text file. So this is one of the RDD, that's resilient distributed databases. So Spark's primary abstraction is this. So Spark's primary abstraction is basically a distributed collections of items, which is called a resilient distributed dataset, or RDD. RDD, it can be created from Hadoop input formats such as HDFS files, or it can be utilized by transforming other RDDs as well. So let's make a new RDD from the text of this RDB readme.file in the Spark source directly. So what I have done, we have just uploaded, we have just taken the text file, the readme text file. Now RDDs also have some actions which returns values and transformations which returns pointers to the new RDDs. So let's start with few of the actions. So the same example what you have done in Scala, which I'm going to do in Python as well. Just applied the count function and I'm able to get the answer. So a number of items in the RDD, it's right now it's 98 in this readme file. Similarly, if I just want to fire another action, it's text file dot first, which should always return the first item in this RDD. So it would show up always the first item in this RDD. Now let's use some of the transformation. So Spark RDD actually consists of a series of actions and transformation. Action means which returns values, and transformations means which return pointers to the new RDDs. So let me just go through some of the transformations. So we will use right now a filter transformation to return a new RDD with the subset of the items in the file. So I'm just writing text file filter lambda line Spark. So it would search up all the lines which are having the word called Spark, and we can again chain together the transformations and actions. Just can write text file dot filter so it would go ahead and check how many lines are actually contain the word called Spark in this file, that's readme file. Now if you want to continue some more operations on RDD, so RDD actions and transformations, it can be also used to calculate more complex computation. So let's say suppose we want to find the line with most of the words. So suppose with RDD we want to perform another operation. Let's suppose count the line with most of the words using Spark RDDs. So what are the steps that we need to write? So basically we can write text file and we can invoke a map function here, lambda line. We can calculate length and just split it. And then call the reduce function, call another lambda, two variables a and b, and can perform an if else. So if a greater than b, then it would return a, or else it would return b, and it could return actually the total number of lines which are having the most of the words. So here the answer is 14. So it's actually the map reduce. The first actually maps a line to an integer value just when creating a new RDDs, and so what is actually the function is been going on. It's just first mapping into a line to an integer value, creating a new RDD. Reduce is being called on that RDD itself to find the largest line count. So This argument to the map and reduce are the Python anonymous functions, which we called as lambdas. But we can also pass any top level Python function that we want. For example, if you want to define a max function to make the code is much more easier. So what you can write to define a max function, we can of course write a function in Python like this. Just perform the check. So next we can write text file. You can map it with, just apply lambda, split it, and then call the reduce function, and in the reduce just apply the max. And here also we are getting the same value, that's 14. So one common data flow pattern is MapReduce, of course, as it is popularized by Hadoop. Spark can also implement MapReduce flows very easily. So what you can write, so we can go ahead just open the PySpark terminal. And here you can just write word count, text file, line dot split, map it with lambda word, So here we have combined the flat map, and reduced by key transformations to compute the per word counts in the file as an RDD operations pairs. So in order to collect the word counts in our shell, we can use simply right now the collect action. So we can write word counts dot collect. So these are the words. Next, Spark also enables specifically as a special feature called caching. So Spark actually supports pulling the new datasets into a cluster-wide in-memory cache, and this is very useful when the data is being accessed repeatedly. So what it does actually, pulling datasets into cluster-wide memory cache, and that's going to be useful when data is randomly or repeatedly accessed. So such as like when querying a small hot dataset or by running an iterative algorithm like PageRank. So as a simple example, let's mark our lines with Spark dataset that needs to be cached. That needs to be cached. So what you can write in Spark shell, now we can perform some caching operations, right? So we can write lines with Spark dot cache, and then we can apply an action called count. So it may seem silly to use Spark to explore and cache a 100-line text file, but the interesting part is that this seems actually that this is the same function that can be used on very large datasets as well, even when they are stripped across the tens or thousands of nodes. You can also do this interactively by connecting the bin PySpark to a cluster, and by using in PySpark. So also Spark also contains some of the self-contained application, and we will show that how to write an application using Python API. So if we wanted to write a self-contained application with the Spark API, so we will walk through a simple application that is built either in Scala or in Java, that could be built using Maven and Python. So we'll just right now we'll show that how to write an application using Python API. So let's go ahead, just type simple app.py, import Spark context class, and just apply the log file. Here you need to mention your Spark home. And after that it should be some file in your system. Take the object of Spark context class, just apply local and the name of the file, simple app, that's all, and after that you just need to add log data, which could be looks like this: text file, add log file, make a cache of it. Once you have done, next just add log data, call the filter function, lambda s in s dot count. So you can alternatively also can write the program in a shell or in a simple text editor, and from there itself just can run this program like this way. Just command your Spark home bin Spark submit. Once you have done that, apply master local 4 and just type the file name. So using this command also you can run this example, this application program using bin spark submit script. So in next line also we need to do the same thing. We need to just type for number for b, and log data. After on log data you need to apply the filter function, so it's a lambda, and you just need to count the numbers of occurrences of words. So this program just counts the numbers of lines containing a and the number containing the b in the text file. So note that you will need to replace your Spark home with this specific location where Spark has been installed. So for this demo I have used basically the default Spark home directory for this cluster, and also just if you're doing with Spark or Scala or Java example, so you just can use a Spark context to create the RDDs. We can pass also Python functions to Spark, which are automatically that needs to be serialized along with any variables that they reference. For applications that use the custom classes or third-party libraries, you can also add code dependencies to Spark submit through its spy files arguments by packaging them into a zip file. Simple app is simple enough that we don't need to specify any code dependencies. So also you can just add bs log data dot filter lambda s b in s dot count. So once we have done that, you just can print it. Just can print it, so you'll be able to see that the total numbers of occurrences of the lines which are containing a, and the occurrences of the lines and the numbers actually containing the word that's b. So it would just count the numbers of lines containing a and numbers of lines that's containing b in this text file, that's readme text file. So basically this is an example, so it's just one of the first Spark programming application. Now if you want to do the same programs with Scala, so we have already shown that how to go ahead with Scala. So Scala is pretty much more simple. So we can of course go ahead with Scala as well. Let's open a new terminal. Just move inside the Spark directory. And here, first of all, let's start the Scala shell as well, the Spark shell, so that we would get this. We'll be able to get the Scala shell as well. So once we are getting, let's start with new example. We have already done it with Python. Just type text file, apply filter, right, start with text file. So now we can chain together transformations and actions together. So just can write text file dot filter line dot contains. So we would count the occurrences of total numbers of lines which contains a word called Spark, and it would count. So transformation action will happen together. So just to check how many lines contains the word called Spark, alright. So it would return already that the numbers of lines which contains a word Spark, that's 19 lines are there. So in this command, what we have done, we have just chained together the transformations and actions in Scala program. Now similarly, this RDD operations, that RDD actions and transformations that which could be used for complex operations, what we have done for Python, we can also include it for in Scala as well. So in Scala we can write text file dot map. We can apply a series of MapReduce. So just could be able to apply the line split, apply size function, then call reduce. Here also just do the same thing. Just type if a greater than b, close it, type else. So that could return the first, actually that would maps a line to an integer value, just creating a new RDD. Reduce is called that, then again on that RDD to find the largest line count. So this argument is basically to map and reduce the Scala function literals, the closures, and can be used in any features on the Scala or Java library. So we can easily call up the function that's declared elsewhere. So we can also use math.max functions to make the code more easier to understand. So what you could do here basically, we could typically write import Java math class. You can import and on Scala we can write map line dot split. Just call the size, then call reduce. So first import the text file. Then import Java math package. Once you have done, then apply the map function. So once you have done, you'd be able to see that the map reduce operations has occurred. So this is a one common flow of data flow pattern, that's the map reduce that we have done. So we have just applying here basic maps and reduce functions, and then we have applied the math max functions over there, so by which you would be able to get the value. And after that, if you want to apply the data flow pattern MapReduce, which is very popularized in Hadoop, Spark can also implement MapReduce flows. So what we have done in Python, we can do the same thing for Scala as well. Just open Spark shell. And next we can apply a word count example. Right. Let's throw an action. Let's put counts collect. So we have combined the flat map and the reduce by key transformation to compute the par word counts in the file as an RDD of string int pairs. So in order to collect the word counts in the shell, so we have used the collect function. So since we have already discussed that Spark also contains support pooling datasets into a cluster-wide in-memory dataset, and which is going to be very useful when data has been accessed repeatedly, so such as when querying a small hot data sets or when running an iterative algorithms like PageRank. So let's mark our lines with Spark datasets as well. So what the demo we have done with Python, let's do the same one with Scala as well. Just calling the cache function. So just let's go ahead with caching. So also we could add the self-contained application, that what we have done for Python using Python PySpark or the Spark API. So we can work through the simple application in both Scala with SBT, Java, Maven, and Python as well. So we just can create a very simple Spark application in Scala. So just for example, in fact, it's named as simple app.scala. So what you can write Scala shell itself, you can build a program. So in Scala, the objects are basically class, each and every class and that's being treated as a simple object. So in Scala, the definition of class is being replaced as an object, and function has to be written as a function definition. quite similar with Java. So this default directory path would be replaced by the Spark home directory path. If you are working for some other directory path in your cluster, so just make sure that you have replaced with your Spark home directory path. Initialize the Spark context class. Just apply there over the object called conf from the Spark conf class. Just import the text file. It's actually the log file. And put it into the cache. And apply the filter action. Just apply line. Apply line dot contains fits contains A to check and count. Then also dot count for B, and it would apply for filter, and here dot go for contains. Apply for count. Finally, to take up the println, just to print lines with A, to print out the string, and lines with B, here also to print out the string, and then the format would be like this. So here in this application, that should have a main method instead of the Scala.app. Subclasses of the Scala.app, it may not work properly. The program would just count the numbers of the lines contains A and the numbers of lines contains B in the Spark README file. So you will need to replace your Spark home with the locations where Spark is installed. Unlike the earlier examples in the Spark shell, which initializes its own Spark context, so we initialize the Spark context here as a part of the program. And we have also utilized here in this program a Spark context constructor. That's a Spark conf object which contains information about the application. Now here, since we have simply the name, version, Scala versions, and library dependencies, because our application depends on the Spark API, so you have also include an SBT configuration file that's called simple.sbt, which explains Spark is a dependency, and the file adds a simple repository that the Spark is going to dependent on. So what you can do basically, for SBT to work correctly, we need to have a layout that's like simple app.scala and simple.sbt according to the typical directory structure. Now how does the simple SBT should defined like? So your simple SBT that could be defined like this. You can just add name as project, version just can add as 1.0, Scala version can add as, and then you can add the dependency library as like this. So in order to SBT to work correctly, we need to lay out the simple app.scala and simple SBT according to the typical directory structure. So once that's in the place, you can create a jar package containing the application code. So, and then of course you can use a Spark submit script to run the program as well. So what you can do, first of all, just go back and type just exit from Scala shell. In here, just type find. And once you have done that, just type simple.sbt. Just create a simple file that's named as simple.sbt. So let's create a file. So you're mentioning the version of Spark as 1.2.1, which is a current version. And once you have done, can just go through. If you're getting a permission denied issue, just give the permission. So like this way, you just need to create a Scala that just need to make in this such a way. So just you need to type to simple.sbt, type src, create a directory called src, then src main, then src main Scala simple app dot Scala. Package a jar containing the application by using the command sbt package. So make sure that you can do this using Maven as well. And once the package has been built up, you can take out the project, that's 2.10.1 jar file, to build out your Spark Scala program, and you can use Spark submit to run your application. So just can type the command, then your Spark home, use the Spark submit command, apply class simple app, use master as local 4, and then just specify the target, Scala 2.10, simple, project 2.10.1 jar. So that should be the command. So in this demo, we have gone through the fundamentals about Apache Spark, and we have just gone through an in-depth overview about just declarations and installation. After installation, step-by-step installation guide. We have just gone through in depth about Spark RDDs, that's a resilient distributed dataset. We have also discussed about interactive shell with the Spark interactive analysis with Spark shell, Spark streaming in depth, and we have just gone through the demos using both Scala as well as in Python. We just gone through in depth about RDD operation, that's resilient distributed dataset transformations and actions using more complex computations, and we have just gone through some of the examples about caching, because Spark also supports the pulling datasets into a cluster-wide in-memory cache. And also we have just gone through a simple program about self-contained application. We just written a program in Spark as well as in Scala. So that's pretty much about the demo, and hope you enjoyed it. Thanks for watching.